Have you ever looked at the names like chloride, chlorate, perchlorate, cuprous, and cupric and thought, why these names are so confusing? Well, what if I told you there are just 5 simple rules that can help you name almost every common ion? Let's learn them in just 5 minutes. Let's go! Rule number 1. A monoatomic cation. A monoatomic cation is a positive ion made up of only one atom. The easiest rule in chemistry is this: keep the element's name and add ion. For example, in case of a sodium, when it becomes a cation, so we'll write the metal name, that is sodium, and we will add a word ion. So it becomes sodium ion. Same likewise, magnesium will become magnesium ion. Al3 plus is known as aluminium ion. So how to remember this? Positive people keeps their identity. Rule number 2. A monoatomic anion. A monoatomic anion is a negative ion made up of only one atom. Now the chemistry changes the ending here. Instead of the element name, we use a suffix IDE. So chlorine become chloride, oxygen become oxide, nitrogen become nitrite. So they've just put the suffix IDE to indicate it is a negatively charged. So memory trick for the same: one atom plus negative is equal to IDE. One other way we can remember, negative ions love hiding, that is the why they become IDE. Okay. Rule number 3. Now let's look at the ion made up of many atoms. So polyatomic cation or polyatomic ions means more than one elements bind together and they are having the charge on the top of it. Like for example, nitrogen is bonded here with 4 hydrogen and it's having a charge positive. So it's a polyatomic. And hydronium, oxygen is bonded with 3 hydrogen, so it's a polyatomic. Now why it is a cation? Because it is having a positive charge on the top of it. Okay, so there are some positive polyatomic ions have some special names. You just have to by heart it, like NH4 plus, it's known as ammonium. H3O plus is hydronium. So what's the memory trick for the same? Positive polyatomic ion have special names. Okay, so these are the two you can remember. 4. Polyatomic anion. Polyatomic, as I explained previously, polyatomic means two different kinds of element binded together and they are having the charge on the top of it. Here it's mentioned anion, so it means it has negative charge. What do you mean by oxyanion, which I have written in the bracket? Oxy means the oxygen, the number of oxygen binded with that negatively charged anion decides the name. What suffix we have to put? So if less number of oxygen binding, then we put a suffix ite. If more number of oxygen binded together, we put a suffix ate. So 8 is actually a past tense form of eat. That way you can remember. So when it is a monoatomic, so we put a suffix ide, which we have seen previously. Now when we are discussing about this nitrogen, one of the nitrogen is bound with 2 oxygen and another nitrogen is bound with 3. So 3 is a maximum oxygen binded with the nitrogen, so we put a suffix ate, so it become nitrate. And if there are less number of oxygen, like here in this case 2 it is, so it is ite. Likewise, sulfur, when it is a monoatomic, we put a suffix ide, sulfide. If maximum number of oxygen binding with the sulfur, that is 4, then it becomes sulfate. Like copper sulfate, you might have heard of it. So why it is so? Because CuSO4. So 4 is a maximum number of oxygen binding together, so sulfate. 3 oxygen binding together with a sulfur, they will call sulfide, ITE. Okay. So it's very simple: IDE, ITE and ATE. IDE is basically when there is no oxygen bind together, less number of oxygen bind together with the sulfur or any negatively charged ion, then we put ITE. Maximum number of oxygen binding together with a negatively charged an ion, then we put a suffix ATE. So memory tip: A comes after I. 8 has more oxygen than I. Rule number 5. Hypo or per. What does it mean? When there are 4 anions, that means oxygen atoms. So we have seen previously maximum or more number of oxygen binding together with an anion, then we put chlorate. At is a suffix. If there are less, that is here in this case with chlorine, 2 are binded together, 2 oxygen binding together, so ITE. Now if it is lesser than the 2, so what we put a prefix hypo. And if it is greater than 3, that means most, if it is most, we put a prefix per in front of the name. So perchlorate here become hypochlorite. Okay, so least, lesser than what it is, then it is called hypo, we will put, but it remains the same. And if it is more, most, okay, greater than the 3, in this example, as in the example, we put a suffix, but rest of the name remains the same, that is chlorate. Ate remains, the suffix remains the same. We put a prefix here per to indicate that it is perchlorate. So the hypo means low, per means plenty. Bonus rule: if the metal has more than one oxygen state, that means it has more than one valency. Like especially in case of a periodic table, if you see D block elements, they are having more than one valency. They are the special character of that D block element. So there are two ways we can write. So as per the old name in many of the textbook, you might have seen ferrous, ferric, cuprous, cupric. So what does it mean? So basically the copper symbol Cu has come from a Latin word cuprum. So in Latin, copper it is known as cuprum and iron is known as ferrum. So that's the reason symbol is Fe. Now what is this OUSIC means? If it is having a lower oxygen state, that means lower valency, then we put a suffix OUS. If it has a higher oxygen state, we put a suffix IC. So for example, here in this case, copper is having +1 valency, and here copper is having a 2 plus. So +1 is less than +2. So we put OUS as suffix to indicate that it is having a copper is having a lower oxygen state, and that is +1. And here we name it as cupric. It indicates that it is the copper is having a higher oxygen state, that is 2 plus. So likewise in case of an iron is having lesser oxygen state, that is 2 plus, so we name it as ferrous. And Fe3 plus, it is having an highest oxygen state, we put a suffix IC, so become ferric. So as per the modern IUPAC name, what we do, we write the name of that element, and in the bracket we write the Roman number to indicate what is the oxygen state of that element. Like Fe2 plus is here, so iron in the bracket 2, we will write a Roman number. Fe3 plus iron bracket Roman number 3 indicates the oxygen state of iron is +3. Likewise for copper 1 indicates Roman number 1 indicates the oxygen state of a copper is 1, and 2 Roman number indicates it has an oxidation station is 2. So OU is indicates lesser oxygen state, and IC indicate higher oxygen state. Today we learned positive keep its name, negative one ends with IDE. ITE means less oxygen, ATE means more oxygen, hypo means least oxygen, per means most oxygen, OUS means lower oxygen state, IC means higher oxygen state. Now you will never have to memorize ion names the hard way again. If this video helped you, give it a like, subscribe to Happy Ions, and share it with a friend who finds chemistry confusing. Until next time, stay curious, stay positive, and keep smiling like a happy eye.